Hello everyone, myself Dr. Anamika Goyal, Assistant Professor at ABES Engineering College, Ghaziabad. Today I am going to discuss about the Unit 5th of the subject Design and Analysis of Algorithm. In this lecture series, we are going to discuss about the various topics of Unit 5th. Let's start with. The first topic that we are going to discuss in this lecture series is string matching algorithm. So, string matching basically it is a kind of technique that is used to find a given sequence of character that is nothing but it is called pattern exists in a given large sequence of character that is nothing but it is a text string. So in string matching algorithm basically giving a large sequence of text string we just find out the given certain one or more pattern that it is present or not in a given text string. The basic application of string matching algorithm is that if I want to find a find a keyword on the available document, then here we can apply string matching algorithm. In this topic, we are going to discuss various string matching algorithm like first we'll discuss about naive string matching algorithm. After that, we'll discuss Rabin-Karp string matching algorithm. Next, we'll discuss Knuth-Morris-Pratt, that is KMP matching algorithm. And last, we'll discuss the most important string matching algorithm, that is nothing but Boyer-Moore algorithm. One by one, in my upcoming lectures series, we will discuss in these string matching algorithm in detail. Also, we also analyze these string matching algorithm in terms of their time and space complexity. The second topic which we will discuss in this lecture series is theory of NP completeness. Here NP stands for non-deterministic polynomial time. Non-deterministic means if I want to know the if I want to know the exact part between the problem to a solution, then these kind of problems comes in the category of non-deterministic problem. The basically in NP completeness, in NP completeness class, this is a class of problem where if you had a solution, then you quickly find out the verify the correctness of the solution that it is correct or not. In NP completeness, it is help us to understand the problem difficulties and guide us toward the realistic approach to design an algorithm. These kind of problems are very important because they appear everywhere in the real life, just like routing algorithm and scheduling algorithm. The third topic that we will discuss in this lecture series is randomized algorithm. Randomized algorithm, it is also known as deterministic algorithm. In deterministic algorithm, basically, we know the exact part between the problem to a solution. Then this kind of problems comes in the category of deterministic algorithm. In randomized algorithm, basically we use random number on at some point of time during the process to make a decision. So these algorithms are often useful for solving a problem where the traditional problems also might be slow or maybe little bit complex. So in these kind of problem, we use randomized algorithm. For example, randomized quicksort. So the next topic which will be discussed in this lecture series is approximations algorithm. An approximations algorithm is basically used to solve NP-hard problem. Basically, the problem where we not able or to find the exact solution for a exact solution in a linear time or polynomial time. Basically, an approximation algorithm, it is a type of algorithm to finding the exact answer. It's too time consuming. Instead of giving perfect answer, approximation algorithm give a solution that is good enough and close to the best answer. So in that kind of problem, we apply approximation algorithm like traveling salesperson problem, which we'll discuss in our upcoming lecture in details. Our next topic is algebraic computations. Algebraic computation in algorithm involve using some algebraic concept like polynomial, matrices, to solve these problems. It focuses on designing the efficient way to perform some mathematical calculations on an algebraic structure. This topic will discuss our upcoming lectures in details. Our last topic in this lecture series will discuss that is fast Fourier transform. So first of all, what is Fourier transform? So Fourier transform is basically a technique which is used to transfer a given data in time domain to a frequency domain. So basically fast Fourier transform algorithm, it is an algorithm used to quickly analyze data by breaking down into a different frequency component. These kind of applications are useful for handling data just like sound, images, or signal or any data that change over time. So these are the various topics that we discuss, that we are going to discuss in our upcoming lectures one by one in detail. These are the references used in our presentation. Thank you.